Okay, so before we start, let us all stand for the singing of the Philippine national anthem.
Mga kababayan, ang pambansang awit ng Pilipinas. Kayang mag-ibig, kaya sa sinangalan, alam ng puso, sa titik mo'y buhay. Upang hininang, kuyak ka ng mag-ibig, sa manlulupin, di ka pasisigil, sa nagatang tutok sa simoy at sa langit ng bangaw, ay hinatang tula, kawin sa pagkayang minamahal. Ang matawad mo'y tagumpay na nag-iibig, ang bituin at karamya kailan pa may magdidinig. Lumalang araw ng walang pagsinta, buhay langit sa piling ko. Ang ligaya dapat may mga-api, ang mamatay ng dahil sa'yo.
We can now be seated. Okay, so good afternoon to each and everyone. Um, uh, our colleagues and also space science enthusiasts. Welcome to HugNayan, Space Science Fora. By the way, I am Sunny. So I'm a Science Research Specialist 1 from ISMDD, and it is my honor to serve as your Master of Ceremonies for today's program. We extend our warm greetings to everyone joining us on site here at the PhilSA conference room, as well as to our participants tuning in via Microsoft Teams and YouTube Live. To formally open our program, it is our pleasure to welcome the Director General of the Philippine Space Agency, Dr. Joel S. Marciano Jr., to deliver his opening remarks. Let us all give him a warm round of applause.
Thank you, Sunny. To my colleagues in PhilSA, to our special guest and resource person, Dr. Joel Villasenor. Yung mga Joel, may ano yun eh. I don't claim to live up to that name, as well as our special guest here has lived up to it. But his full name is Dr. Jesus Noel Villasenor. Okay. Thank you. Yes, we know him as Joel. No? He is a space plasma astrophysicist from Massachusetts Institute of Technology, Kavli Institute. So we're all privileged here this afternoon, physically in this room, and everybody viewing online, to be able to listen to the insights and sharing of a very seasoned expert and researcher who has explored well beyond Earth, no? Through his capabilities, applying his know-how, and with continuous dedication to keep learning, which is something that certainly dito sa PhilSA we're also trying to live every day. You know? Right now, our programs are, as you can see, mostly focused back down towards Earth, but all of us being part of a space agency, and especially the ecosystem and communities that we're trying to build, we have to also keep our sights towards vast expanse of the universe. No? And so it is my privilege to welcome all of you today to this special session. Normally we hold this in the morning, but now in the afternoon. It's not too much of an inconvenience, I hope. So we are honored to have Dr. Jesus Noel Villasenor, leading expert in space science, whose contributions to this field have helped expand humanity's understanding of our universe. Through his work on NASA's Transiting Exoplanet Survey Satellite, TESS, TESS. I first learned about this a few years ago when actually Dr. Joel and his brother, Dr. Nick Villasenor, came to PhilSA, and you brought a book of this. Flip through it, it's a picture book. Your picture is there quite prominently with the rest of the team. But I know that you are working with a team as well, interdisciplinary team who have come together to solve these challenges together. Now, through his work on NASA's TESS missions and other groundbreaking missions, Dr. Villasenor has helped chart these planets or exoplanets, and maybe, of course, possibility of being able to discover life as well in these environments that are really, if you look at it, so far from us, but then we have some connections to it as explorers ourselves, right? So we thank the Fulbright Specialist Program and the efforts of my colleagues here in PhilSA, particularly the Space Technology Missions and Systems Bureau, led by Dr. Mark. Together, we've had this rare opportunity to host Dr. Villasenor here in the Philippines during this visit. It's like not that long, but we really hope that after this there could be even longer and deeper engagements. While he's here, we have taken full advantage of his expertise, and this is one of those occasions where we're doing that. The team has brought Dr. Villasenor around the country, has engaged with students, researchers, some industry groups, other scientists and professionals, wherein we not only share know-how, but quite important is to create inspiration with these discussions, so that we can all be uplifted and say to ourselves that we, as Filipinos, we can certainly, as we say, reach beyond the stars, and try to discover what's out there beyond us, not necessarily seen in every day, but otherwise we know that exists. And the quest for this passion for discovery and the quest for expanding the boundaries of know-how should transcend boundaries and borders. Okay, so today's talk comes at a time where we have some momentum, through our satellite development efforts, space development, satellite imagery, space data mobilization. Of course, it's very important also to keep our sights beyond our planet. And we talk about we've also been talking about our space industrial plan. We're trying to, I know Dr. Villasenor is also contributing to that while he's here, and hopefully even as he goes back, or maybe comes back after that immediately and then stays longer, then we can continue working on implementing this space industrial plan, which involves launch systems, which involves satellite components and other things that we can start building again, or building more in our country. Okay, so this is one that's really very exciting for all of us, where young Filipinos can continue this quest of building these satellites and spacecraft, and even new spacecraft, not only satellites, but perhaps rovers and other kinds of space probes, even contributing to the mission of TESS and its future versions of discovering exoplanets. So we are now, to end, allow me to express my sincere appreciation and gratitude for opportunities like this that really help build our agency and make it stronger, and at the same time allow us to reach more people with such important content, with such important inspiration. Remember, everybody, our mission is not just to build this agency and strengthen it, it's to build the entire ecosystem in the Philippines. So keep your sights not just inwards, okay? Train them as well to look outwards. And every day as we report to work here, while we do our business in the office, our sites, you know, our sentiments, our thoughts are always about how to expand, how to reach more people, how to expand our know-how and knowledge for our country and for the rest of the world. So this might just be a lecture, but it's really more than that. It's an inspirational one, which I know Dr. Villasenor will deliver. So I thank everybody, and let's continue strengthening, fortifying our Yamang Kalawakan. Maraming salamat po. Pasalamatan. ISMD, sino ba organizer nga nito? ISMDD. O yan, habol na lang. As always, my gratitude to our Space Science Missions Bureau, ISMDD. Thank you.
Thank you very much, Dr. Marciano. To provide a short context regarding this event, again, HugNayan Space Science Fora is a knowledge-sharing initiative organized by the Interdisciplinary Space Missions Development Division. This event aims to deepen understanding and foster greater appreciation of space science among PhilSA personnel and also to our external partners. We hope this forum leads to meaningful exchanges, new collaborations, and innovative progress in the field of space science research. And to introduce our distinguished resource speaker this afternoon, may we call on Dr. Mark Cesar R. Talampas, Director 4 of the Space Technology Missions and Systems Bureau.
Thank you, San. Thank you, Sunny. Good afternoon, everyone. I'd just like to say you're in for a treat. I've been with Dr. Joel for the past few days during our visits to Ilocos and Davao and Cebu. I think the talk he'll be giving is something that he's given before, but every time I've listened to it, lagi ako may napipick up na bago. So much more so for those who will be listening to it for the first time. So it's my honor and pleasure to introduce our guest lecturer, Dr. Joel Villasenor, a pioneering figure in the field of astrophysics and a true inspiration for aspiring scientists across the globe, especially in the Philippines. Our speaker is an Ateneo Grade School and Philippine Science High School alumnus. He obtained a physics degree at the California Institute of Technology in 1984, and then obtained his doctoral degree in plasma physics at the Massachusetts Institute of Technology in 1993. He then joined the Kavli Institute for Astrophysics and Space Research as a postdoc fellow in 1996 in search of gamma ray bursts with the High Energy Transient Explorer, or HETI. He built one of the main instruments on board the satellite, an X-ray camera that can localize flashes of X-rays to within a few tenths of arc seconds over a 90 by 90 degree swath of the sky. Later on, he developed and upgraded the X-ray camera for attitude determination on the DARPA X-ray navigation project. Dr. Villasenor is the project instrument scientist of the Transiting Exoplanet Survey Satellite, or TESS, as you've heard from DG. It's a space telescope designed to scan the entire sky for exoplanets. It's currently monitoring over 200,000 stars and searching for the so-called Goldilocks planets. Those are just the right distance from their stars to potentially support liquid water and dust life. So I may be spoiling some of your talk, Doc Joel, I'm sorry, but I'm sure there's a lot more you can say. His professional experience includes working on spacecraft systems and detectors, ionospheric modification experiments, diagnostic development, extremely low frequency or very low frequency applications, and magnetic fusion or tokamak research. Through his work, Dr. Villasenor not only advances our understanding of the universe, but also symbolizes the boundless potential of Filipino talent on the global stage. So please join me in giving a warm welcome to Dr. Joel Villasenor.
Thank you, Dr. Mark. So first of all, I'd like to thank Dr. Marciano and PhilSA for inviting me and for here to work on the Fulbright program. Through their that I finally got the the application going and got me through the hurdles that eventually allowed me to be here with you. And also thank you to Dr. Mark and Vic, who have been with me on the road. I think we make a great team because Dr. Mark has also been telling us the story of PhilSA, because PhilSA is sort of like a new organization. A lot of Filipinos have not heard of PhilSA, and Dr. Mark has not only played the sort of like the opening act, but he has also done an effective job in conveying that we have an active Philippine space program. So thank you, Dr. Mark, for that. Okay, so this is the talk that I've been giving. If some of you have watched it on uh, on, uh, on previous channels, maybe you, like Dr. Mark says, you can pick up a few more things in here. But in case you want a second one, I had another presentation talking more about the tests and some of the really cool science that's happening from the test scene. So okay. Let's see. Advancing. Okay. Yeah. How are we not advancing here? Kanina ba yung ano? Next. There you go. Sorry for that glitch. I think I should start by saying I've been working in this field for like 3 decades now, and I'll start off this talk by telling a story or three stories really, because they sort of mirror the kind of things that astrophysicists were interested in at different stages. So the first one was the HETI project, where we talked about gamma ray bursts, because back then in the 80s and 90s, this was the deep and abiding mystery that a lot of people were very interested in. Then followed by the neutron star interior composition experiment, which is the NICER, where we worked on millisecond pulsars. And then finally, the new mystery that a lot of people are really jumping on and coming up with really, really great science is the transiting exoplanet survey satellite, which is a search for planets outside our solar system. So story number one. So gamma ray bursts, what are they? Very powerful explosions seen in different happening randomly in different parts of the sky. So it's almost as if you had something as bright as the moon show up briefly for a few seconds and then disappear. But of course, the brightness is in gamma rays. Gamma rays. And they were first discovered when people were looking for nuclear explosions on the ground back in 1967 with the so-called Vela satellite. The Vela satellite system was looking for gamma rays coming from the ground, and they're actually a set of satellites, so they can actually localize the the point where the explosion happened. And lo and behold, when they looked up in a different direction, they were getting a lot of these explosions. They said, wait, why are nuclear explosions happening in space? Are the Russians exploding nuclear devices? And the answer is no. And it turned out that these explosions were happening from the very, very far reaches of the universe. Make a long story short, they are actually coming from different galaxies, because when you have a gamma ray burst, it's actually the birth of a black hole, most likely, because when you have a supernova explosion, when it starts collapsing, what happens is that it's usually massive enough to turn all of the remaining material into a black hole. And in the process of a supernova explosion, usually what you have are jets streaming out on the poles of the explosion. Now, if you can imagine one of those jets pointing at you, that's what we're seeing when you have gamma ray bursts. And the neat thing about it is that it tells us how stellar mass black holes occur. That because another interesting thing is that we're finding out that black holes come in different sizes. What we're finding are the like sun, like a few solar mass black holes. That's how they form. But it turns out that black holes are very ubiquitous. You find them all over, different sizes. In fact, black holes, supermassive black holes, are at the center of each galaxy. They're sort of like the cornerstone. Ours is in Sag A star, or in the Sagittarius constellation. It's there. It's a 2.1 million solar mass black hole. It's sort of like our foundation. And it turns out that supermassive black holes also have a apparatus where they create stars. They have induced star formation, and an important part of the life cycle of a galaxy. So anyway, that's our satellite over there. That's during the mass properties, where you sort of like start weighing it and you spin it. And I'm sure some of you might have seen the mass properties table. It was also fun because that satellite was folded in and placed inside one of the Pegasus rockets there. It's an airdropped rocket, and it's taken up by an L-10 aircraft and then dropped from a height of about 30,000 feet. And that's how we launched it. So that's story number one. Story number two, millisecond pulsars. How many here have heard of millisecond pulsars? Okay, millisecond pulsars are neutron stars that spin very, very fast. Now imagine when you have a large star, when it burns most of its fuel, what happens is that it first expands and then just contracts. And then what you have are it's sort of like a dead star, what they call dead stars, because they don't really emit a lot of light, but they're very, very dense, to the point wherein if you take a sugar cube size of neutron star material, it has the same weight as, say, like Mount Everest, or one big mountain. And so, or another way of thinking about it is that you take our sun and make all of its mass into a very, very tight ball the size of, say, Metro Manila, or a few tens of kilometers. That's how massive, and I mean, that's how dense these things are. And the thing is, some of them can actually spin for thousands of times per second. And the reason why they're pulsars is because they usually have some hot spot that emits on the surface. And so when it spins, that hot spot becomes visible. And so you have sort of like a lighthouse effect when that happens. Now, why is this interesting? Well, for most physicists, theoretical physics, this is sort of like at the heart of extreme physics, where you have very, very dense objects. This is where they are in the range of what they call degeneracy pressure, when you have sort of like quantum mechanical effects, essentially balancing the force of gravity. So and what they're interested in is the equation of state, because that's still unknown, and there are many, many theories trying to figure out what the equation of state is at those densities. And our device here, which is what you see over there with the multiple, that box. Do I have a pointer? Laser pointer? Oh, okay. But anyway, when you have that box over there, it can point at millisecond pulsars and basically gather the X-ray pulses, which tell us how fast the pulsars are. And also, as a result, we can also figure out what the radius is based on other factors that we measure in the pulse shape. So I also was there developing the electronics for that, and it's great because it's still there on the International Space Station. You see that little red dot over there? That's us, and that's that device. For engineers and space enthusiasts, this is important because it turns out that when you're traveling in deep space, a lot of our satellites, like the Pioneers, Voyagers, and whatnot, in order to get their timing information and also figure out the fix in the sky, they have to sort of like contact the and get their timing from the so-called deep space network, which transmits to them the signal. Now, one of these days, when we are doing a lot more traveling, to interplanetary, the DSN is going to be overloaded when all the satellites are trying to download their data and try to get their fixes there. And so it turns out that these millisecond pulsars are very, very accurate clocks. The Allen variance is very small. So, over long periods, you can actually get very, very good timing numbers from them. And so this was one of the DARPA missions, try to do X-ray, just not only timing, but you can also try to do X-ray navigation, and using something like a soft X-ray camera that I developed. So that's a side note for that. Anyway, story number 3, and this is the Transiting Exoplanet Survey Satellite. TESS. This is the latest project because it was only like in 1995 that the first exoplanet was detected. And as a result, Didier Queloz and Mayor got the Nobel Prize for that. Because prior to that, the number of planets that we knew of was just in our solar system. At first, we thought it was 9, and then we said, Pluto is not a planet, so we took that out, and now we're on to 8. And although I think there's now a good chance that TESS itself might even find planet 9 because there's a postulated planet 9. Anyway, we launched in 2018, and we're still in operation. We expect to be in operation for the next 5 to 10 years. And so far, we found 7,500 planet candidates. And that number 620 confirmed exoplanets, we expect that to be even larger. But here are a few takes in here before we move on to the subject. We were talking about trying to find life outside our planet, and in fact, that's one of the missions of the NASA Decadal Survey. Where's life? I mean, are we alone? Okay, so in order to find life, you have to find places where it can be in, and the obvious choice is on planets on other stars. And once you go down that hole of trying to figure out what's going on, the next question is, how often do planets occur, with each star? And prior to that, people didn't really know. Maybe it's like 0.1, like 1 out of every star, maybe 2 out of every stars will have a planet. No, the answer is, it turns out that every star that you look up in the sky has a planet. And not only just one planet. We're starting to build a list of exoplanets which have multiple planets. It's hard for us to find the planets on each star that we see, because our method of finding planets is called the transiting method. So in other words, the planet has to cross in front of the star to our line of sight in order to see it. So, the most planets are in orbital plane, so that orbital plane has to be oriented towards us. So most planets, though, have planes which are not directed towards us, so we can't see that. But from the statistics of the number that we're seeing, we are coming to that conclusion that planets do occur on just about every star. And it doesn't matter what kind of star. It could be a binary star. It could be a neutron star. It could be a white dwarf, very bright stars, or M dwarfs, all types of stars, the whole thing. I mean, even Proxima Centauri, that's the closest star system to us. I mean, who's here has read that that book that recently came out, the series of the 3 books, turned into a Netflix series, The Three Body Problem. Yeah, they were talking about Proxima Centauri, which is a binary with a double binary and a star. So that actually has a planet, but it's not the chaotic system that's depicted in the book. But anyway, so yeah, there's a planet or planetary systems with each star that you see up in the sky. So those are my 3 stories of where astronomy is. And the thing is, I keep saying this, astronomy is in a continuing golden age of discovery. I think it started in the 1980s, 1990s, and when I first started giving a talk on gamma ray bursts, I was already saying that. But the thing is, 20 years later, it's still the same situation. We're finding out a lot of amazing things about our universe. Cosmology, for example. I just heard over the news today that dark energy, which is causing the expansion or acceleration of the universe, well, we're finding out that dark energy is not necessarily constant since the time of the formation of the universe. We're seeing a lot more planetary probes to go to some of the moons of our own planets. And I just told you about black holes, but there's actually a new component because now we have gravitational wave astronomy, which is really, again, another cool thing, and also more stuff on exoplanets. Now, most of these discoveries were because we had spaceborne satellites. A lot of the discoveries in cosmology and whatnot couldn't have been found if we did not have the capability of putting our instruments into space. And since the 1960s, when we started sending up satellites into space, we've sent out dozens and dozens of these. I mean, just for the exoplanet field alone, this list of planets that you see over here, they're actually just looking not just for exoplanets, but mainly for exoplanets. And TESS itself is just one in a long line of this series. I mean, I marked this 2018. That's when we launched. But in the meantime, Cheops, Webb, and Plato are up there. Well, Plato not yet, but will soon be. So anyway, we have a lot of satellites that are doing the hard work. I don't know how much I should delve into this value of space access, but these 3 areas here, global navigation systems. This is the time when I hold up my cell phone and say, hey, look, every time I have this, I have multiple satellites talking directly to my phone. My phone is a receiver for 3 satellites that help me pinpoint my location. It's very important, right? It's so important that in terms of war fighting, GPS is the thing that a lot of nations are trying to develop on their own. Galileo is part of the European system. You can see that down here. GLONASS and Baidu, and I don't know who else is in the market right now or trying to create their own system. Then you also have communications. We've had broadcast TVs for the longest time, but since everybody wants internet anywhere on this planet, including in the deep forest of Mount Apple or something like that, you still want to be able to do your Facebook and social network. So yeah, it's coming to that point where the same cell phone will have internet connectivity anywhere on this planet, where it actually connects to a satellite and connect directly, so you don't have to use a cell-based tower. Earth sensors, that's you. You have a lot of satellites like Mula and whatnot, so we do that. So these are the typical areas for space technology. But let me, if you haven't seen this, to me, this is sort of like the next frontier. We're not starting to do production facilities. Now, what are we trying to produce in space? Turns out that you can produce a lot of really good pharmaceuticals like monoclonal antibodies and HIV medicines and interferon, because in microgravity, the protein crystals really form much better, and it's also dust free. You have less contaminants. So much so that a lot of companies, including BARDA, you see that bottom picture over there, there's that little probe. They're starting to come up with ways of producing these chemicals, not chemicals, pharmaceuticals in space, and then just recovering them. This is actually the first BARDA satellite facility that they have. It went on board the transporter on the SpaceX, did its thing of creating pharmaceuticals, and then just did a re-entry. They're actually now into like the third satellite, and they're planning the fourth. So the pharmaceuticals are not necessarily just formed in free-flying satellites, but they're most likely going to be formed in space stations, and that's why space stations are going to be very, very important in for these manufacturing facilities. Bioprinting, people are making human tissue and cartilage. There's actually a bunch of biomedical companies that are trying to do a lot of these experiments in space to try to produce new cells. They're trying to get the stem cells to grow so that you can repair certain tissues in your body. If, like for example, the eyesight, in the eyes, that will improve your vision. Semiconductors grow much better because, again, it's a clean environment, and more advanced materials like heavy metal glasses, which you find in optical fiber cables. And of course, you have a lot of patents that were initially developed for space, but it turns out that they are very useful for terrestrial applications like camera phones and scratch-resistant lenses and LEDs. Right now, it's a $630 billion industry in 2023. Oops. But there's it's increasing in activity. So in about like 10 years, the activity will grow threefold. Currently, there are like 12,000 satellites in orbit. You see that little image over there? That's the Earth, and of course, that little fuzz around the Earth is where a lot of the satellites, the LEO satellites, are. And the little ring that you see over there, well, those are the GEOs. And of course, you have other satellites that have different types of orbits. And of the 12,000 satellites in orbit, 7,200 are with SpaceX Starlink alone, and they are planning to increase that to as many as like 10,000. And they're not the only internet service provider. They have competition coming from Amazon and their Kuiper program. Kuiper, for example, needs to put 3,326 satellites very soon, and they have to put that in orbit by half of them in orbit by July of 2026 because of FCC. There's an FCC license that they have to fulfill. We expect to increase the number of satellites to 60,000 by 2030. So there's just a big demand for putting these objects into space. And not only that, you have a lot of space station activity. NASA has this thing called in-space production program, where they just recently announced 8 proposals going into biomedicine and et cetera, to try to produce things on the ISS. China isn't far behind because their Tiangong space station is doing similar things. They're trying to come up with better production methods for better materials, better sensors, better everything, to the point that they're planning to expand the number of modules from 3 to 6. Now, why is this happening? You see this curve, this plot over here? This is the cost curve. In the early start of the space program, the cost per kilogram of sending something up into space can get up to about $1 million per kilogram. And then, of course, during the Cold War, that curve, went steeply down because there was a lot of money being spent by the United States to develop a lot of the rockets. Apollo, the Apollo series of rockets was the ultimate rocket that can send a huge amount of mass into space, and relative to the cost, it was able to kind of start bringing that cost curve down. But after the United States won the space race, so to speak, by 1970, there was less interest in that, and people started saying, "Hey, what's the next step? How can we still do a lot of the things that we said we want to continue after landing on the moon?" Well, it turns out that, hey, let's try the shuttle. Maybe it's a reusable plane. Send it up. The cost of the rockets is not so much, but afterwards it will just come down, and then you reuse the shuttle. Well, the problem with the shuttle is that it never did bend the cost curve. We still stayed fairly high up there, except most recently, and it stayed there until most recently we started doing something like that. But just as a quick aside, as we all know, making rockets is very difficult. So a lot of the rockets that we send up are still blowing up every now and then, like that's a Starship. And one of the reasons why the shuttle program never really worked was that they were still blowing up far more than people could accept. I mean, like there were 3 accidents that happened out of like a total of like 30 launches, and so that was a very unacceptable rate for the kind of cost it was going. So not only did it not break the cost curve, but it was still killing astronauts at a far too high a rate. So it's just because it's really hard. So why is the cost going down now? Well, the answer is reusability. Back then, you used the rocket once and that's it. The similar comparison is that you use a plane once and then you throw it away. Well, you're going to cause the cost of a plane fare to go from like a few $1,000 from here to New York to several $1 million. So the thing is, you can bring the cost down because you're able to use that same plane over and over again. And so SpaceX was one of the pioneering companies that introduced this method of reusing the flight, and this is their most successful rocket. This is the Falcon 9. Mula is going to go on a Falcon 9. I think most of the other, well, some of the satellites went on Japanese rockets, but Mula is going to go again on a Falcon 9 in one of their transporter series. Since the first flight in 2016, this is like only about 9 years ago, they've had 481 launches and counting, and the cadence is approaching 1 launch every other day. And some Falcon 9 boosters have already flown more than 20 times. The record is 28. And the interesting thing is that success breeds a lot of copycats, and that's why a lot of the other companies that you see are following the SpaceX model. Some Chinese companies are actually following the dimensions almost exactly. But you know what? This is what happens when you have a lot of competition. It brings a lot of similar companies doing that, and that's fine because the competition will bring the cost further down. This is how they make it work, right? So here's a typical flight. It starts launching. And then once it's at a certain altitude, the second stage separates, and then the booster turns around, flies back, and lands on either a barge or on the ground. I'm sure you. I hope everyone here has already seen this because this is sort of like so very common. But the thing is, they also do a lot of cost saving. Like for example, the fairing, the fairings that cover the satellite, they're also recovered because they fall down. Usually they tried the parachute recovery, but it turns out that let it just sort of like glide into the ocean and make it salt proof. But it's really impressive. I mean, it's still quite fun to see one of these barges coming into the dock at Florida and be recovered. But the second stage is not recovered, so that is lost. So with this kind of technology, SpaceX could have just said, hey, we are really at the top of the market, and they still are, and make a lot of money, and they can. But the thing is, they haven't stopped. So even while they were making a lot of money out of the Falcon 9, they said, well, we're already developing the next rocket, and that would be the Starship. I'll skip this part, but the next big rocket is the Starship. And so what you see here is essentially the Starship, which is the upper half there, and the bullet-shaped thing, and then the booster on the bottom part. This was a picture I took over in Boca Chica. It's kind of great because the Starship, the SpaceX facility over there is fairly open. It's a very powerful rocket. It's got 3 times the power of Apollo, and can lift up to payloads of about 150 tons into orbit, and uses a fuel of methane and oxygen, aside from the usual kerosene and LOX. They have very efficient engines, and they're making a development cycle very quickly. Who knows here? Who here knows how the booster is recovered? Yeah. So there's the same launch facility that launches the satellite has these things called the chopsticks, and what you're seeing over here is a way for the rocket to come back precision, and it has these little knobs, 2 knobs coming out on the side. Comes in, and the chopsticks, if you notice, the arms are moving and closes in on the rocket. Absolutely amazing. And again, if you look at this thing closely, the projection on the side is not much further than my own arm over here. So that's how close the little projections on the side have to be in order to make this catch. Can you imagine if the rocket was just sort of like tilted, skewed by just so much? That means the pegs are not going to catch on the chopsticks, or if the chopsticks just don't close in enough, a certain amount. There's so much potential for this thing to come crashing through. But they've already had 2 successful catches, and I think they've just about got this almost pretty much settled. So there's a lot of testing. Who here has heard of Flight 9, the recent test? Yeah, it didn't work too well, but the thing about SpaceX is that they have a very fast cadence and a philosophy of using mass production. You make a lot of the same thing, kind of similar, but you kind of tweak it and solve the problem as you're mass producing, which means that they will have a very fast cycles, almost like similar to what you saw with the Apollo program. Very, very fast development cycle. And the next launch, I wouldn't be surprised, may happen in 3 or 4 weeks. And why are they making the Starship? They already had a profitable rocket with the Falcon 9, and yet here they're developing the Starship. Why is that? They're absolutely serious about creating a Mars colony. So they're not really making the Starship to just put more satellites and stuff into space. They really want to go to Mars, and so in order to start a Mars colony, the idea is that you have to have at least like 1 million people on the planet. And to get that number of people and materials on the planet, you have to have such a large capability rocket, and at the same time produce thousands of these things. So producing thousands of this thing, is that possible? The answer is yes, because they're now starting to make a factory right by Boca Chica to do that. And not only that, they're making it cheap enough to make thousands of these. What's the approximate cost of the Starship and booster? Well, probably on the order again of making one airplane, one A321, because they have a lot of the production methods and facilities down. So it's starting. This is an old picture. If you look at the picture of Boca Chica, you'll find that some buildings are already up. So those 3 buildings that you see there have been torn down and been replaced by different buildings. So they have a very, very fast change cycle. Now, the thing is, even if you don't want to go to Mars or you don't care about going to Mars, a large rocket like this really opens up doors because it decreases the cost of satellite development and also promotes human activity even in Earth space. So a lot of you over here are also going to be, hopefully, will try to develop commercial off-the-shelf products to be turned into space uses. That used to be a very big hurdle, turning a COTS product, because there were so many regulations, because the cost of getting a kilogram into space was so high. But once you lower that, that means that you can relax things a little bit. You can afford to make mistakes, and you can afford, if you can afford to make mistakes, then you can afford to really innovate. So that's why I think the COTS thing is a very important thing. The other thing is that the cost of sending astronauts into space becomes cheaper, and for any activity on this planet, I think you always have to have a human being in there. I mean, I guess we're now in the stage where we can do things remotely. We send remote probes and whatnot, but nothing excites the imagination and the public's confidence and the public's interest than by actually sending, a human up there. So you can actually, and that's why the human space program of NASA never really stopped, even though there were a lot of people saying that's so expensive, and compared to the kind of science that you can produce, a lot of the space programs have maintained the human space flight areas. When they were saying cut off the shuttle, let's just build more great telescopes, which astrophysicists would love. It turns out that they held steady and say, yes, let's just have humans in space. And I think this is a very important thing. You'll have more space production. In case you hadn't heard, they're already planning to build additional space stations up there. The International Space Station has a shelf life. As great as it is, they're planning to decommission it by 2030. and there are already replacement things up in there. Like Orbital Reef is creating an inflatable habitat. I've seen some of their tests. They're great. You know, they try to explode them. They have a lot of tensile strength, so you'll have a lot of confidence that, you know, if you're in one of them, that you won't get blown up in space because there was a little hole, as you would see in a lot of Hollywood movies. You also have tourism that's starting to happen. You know, the whole Katy Perry thing going up into space. So I think we'll need a lot of people of all types. I think we have to get the public confidence and acceptance into going space. It's not an exclusive club anymore. It's not, oh yeah, I got to be a fighter jock, you know, with you know, fighter credentials and, you know, fit body and, you know, very healthy. No, we're going to have young people, old people, thin people, fat people, all types. They're going to be in space because that's what we need, because we send people up into space because they have a particular use for the program, and so we can't exclude the greater rest of population. So anyway, tourism, the lunar program is alive and kicking. I've been on some lunar programs. We're really very serious about going into landing on the Shackleton crater, trying to find water and mine water. The other thing is that the Artemis program is also being there's strong competition because the Chinese and the Russians, they are banding together. They're going to try to put their own conglomerate of space activities, again on the same area where people know that there's a little bit of water. So you expect to see something along those lines. And the last point, global point-to-point travel. If you think that space rockets were just to go into space, think again, because you can use these same rockets to travel very quickly from any point on this planet in less than an hour or so. And that is actually a very serious consideration. The Department of Defense is going to plan or has a plan to do a test in 2026 for just that purpose. So I get to the part where I get to exhort the crowd here because this is a Filipino audience. The increased access to space has brought in more people. So here's my stat. Since 1961, 682 people have gone into space. And this is the time I asked, how many Filipinos are there in that 681? And of course, the answer is, right? So 47 countries, right? They have Indonesians, they have Saudis, they have all sorts. But given our population, we still don't have any. And why is that? It's also because the cost is very high. Okay, early on, the cost for training and access, you know, that was high, but it's going down. So what do I mean? For example, if you want to go on a zero-G flight, you can go on a zero-G flight if you have it's for the cost of a business class ticket. Okay, it's not even well, yeah, business class, first class ticket, but you can get on one of these rides, easy. If you want to do if the first Filipino is going to be going on a suborbital flight, you can sign up right now with Blue Origin for $300,000. So, you know, there are a lot of rich Filipinos I know who can spend that. There might even be one who's being sort of like trying to solicit. I don't. That can happen right now. But here's my next question. How and when does our nation want to join the ranks of the spacefaring nations? We are going to be a spacefaring nation whether we like it or not, because with all the global activity going into space, there's going to be a first. Okay. Now, how do we want to do that? Well, you know, I suggest that the first Filipino in space would go on sort of like a space mission, a real space mission, and not just sort of like a tourist watching things, like go on the Axiom Dragon, because the Axiom program, when they send up their Crew Dragon, they send 4-man teams, right, from different nations. The latest one I think is going to have a Pole, a Hungarian, an American, and I don't know. They're really different nationalities now. So that's an option for us. I mean, for $55 million per seat. Well, we don't need to have all 4 seats. Let's just have one. And with that, you have the opportunity to send our astronaut to go to the ISS, do Filipino-related experiments, like even the simple thing like the health, the physiology of Filipinos. How are Filipinos suited for the space environment? And yeah, you can do that. Now, how are you going to puff up $55 million? Well, there are actually a lot of, I don't want to take it out of the government, for example, because the Filipino taxpayers will say, no, you can't do that because there's just so much else that you want to invest. Okay, fine. So what you try to do is you try to go to the private investors. I was talking to a Filipino media executive, and I told him, what do you think about this $55 million price tag? And he told me, yeah, sure. Because a lot of companies spend, different amounts, for they have these things in their budget. But the thing is, this number here kind of represents what we can do as several groups, as a nation, because it's not just Jollibee that's going to do this. It's going to be multiple companies. I think it has to be sort of like a group effort. So not just aside from the government, aside from the private. And I think this is a kind of program, getting the first Filipino into space can have a higher visibility and bring more talent and critical mass to the Philippine Space Agency. So, with this, I think this is the kind of exciting thing. And things are moving so fast that don't think of 10-year cycles, of waiting 10 years for this thing to happen. Because, like I said, I mean, some rich guy can just pay $300,000 and he's the first Filipino. But the first Filipino in space is going to be a hero of some sorts. There's probably going to be a lot of media. And I think, if we sign up to something like this, we can easily do this thing in a 5-year program, even shorter, if we start pulling strings left and right. Anyway, that was my long pitch for that. Pardon if I am enthusiastic about this portion here, but I think as a Philippine Space Agency, you should also start thinking about these kind of possibilities, because you're not just in here to do satellites and look down on the Earth. You're here to be part of the spacefaring community of nations. So start thinking about things that you can do on the space station, or maybe even do some engineering that they'll need for the Mars colony or the lunar colony, or even the space hotel. And so it's a big ecosystem that you're going to be part of, and that you're going to be leading the Filipino nation too. So there's my summary. Basically, we're having reusable rockets, which is bringing down the cost of space flight. We have a lot of commercial space that's expanding, and we'll have a growing human presence in the space economy. So with that, thank you very much for listening, and I'm here to answer your questions. Thank you.
Thank you very much, Dr. Joel Villasenor, for that highly engaging and insightful presentation. I believe everyone here today, both on-site and online, has gained valuable perspectives. At this point, we now open the floor for questions. Kindly introduce yourself along with your division before asking your question. And for our online participants, via the chat or comment section, and are you suspect? Are there any questions from the audience?
Hello, thank you very much for the wonderful presentation. I'm Elison Castro from the Earth Science and Space Mission Studies Division. Um, I would, I have two questions. The first one would be, how about space elevators?
Okay, that question was asked, and um, I find it problematic in the sense that yes, it can happen. You know, if but it has a very steep engineering challenge because you have to have very high tensile strength materials, trying carbon fibers, and there's also a little bit of physics which I'm not completely sold on because the idea is that you're going to try to do some kind of balancing to get this thing. But the real problem is the material selection. You know, trying to get the high tensile strength materials to that can withstand the really strong forces that can happen. But I haven't really seen any particular breakthrough that's on a short time scale that can make space elevators happen. But yeah, so maybe in the longer term. But I think what's happening right now with rocket technology is far going to overtake space elevator innovations. So
Okay, thank you. And for my second question, I would just go back to the gamma ray bursts.
oh, great.
So I'm kind of curious on the leading theories on how certain stars for star formation actually or galactic events produce these gamma ray bursts.
Okay, the gamma ray bursts are. I had a very short thing on gamma ray bursts here, but they're actually a second type of gamma ray bursts, and that's when you have a merger event. For example, binary stars are very common. In fact, half of the stars in the sky are in binaries. And what happens is that you can have neutron stars in spiral and collapse, and that can produce a gamma ray burst as well. So there are different types of gamma ray bursts, but they're really on the stellar mass level. Is that what you were wondering about, or were you referring to something else?
I'm curious on other than the binary systems. For example, other events that could produce, or how do these events produce the gamma ray bursts?
Yeah, they have to be on stellar level because the shortness of these events, the time scale tells you how large the system is. If for example, if you're looking at say like quasars or blazars, right? Those are huge systems, so the time scales at which you see any kind of emissions will be on much longer time scales. Gamma ray bursts are really just particular to that smaller class of events or mergers. I don't know of anything else, you know, on a larger time scale that can produce gamma ray bursts.
Then it's okay. Thank you very much.
Yeah.
Any questions?
Hi, I'm Chris Angelo Villasenos, an intern at the Earth Science Space Mission Studies Division. I study at New Era University, and I was just wondering, you mentioned something about the exoplanets. Part of my thesis is how I can integrate it to like the undergrads or the upcoming undergrads, freshmen. And for you, how would you integrate it to them? Like, since I had a survey where grade 12 students and grade 11 students are really interested in astronomy and would like to be part of it in the future. So as upcoming freshmen, how would you like mm, integrate the exoplanet study to them or any other space related field?
Okay, first of all, the internet, it has a lot of really open sources So TESS alone, it has many data archives which are open to the public. So you can actually download the full frame images from TESS and actually do your planet searches yourself. And that's because there's so much data that has been collected, there's not enough people being able to do all of the searches. So that's why there's still citizen science happening in astronomy. Like I don't know if you've seen any of the citizens science efforts where they basically ask people to look at data and try to make their guess, whether this is this or that. The reason is because they're also trying to train the AI models, the input from that is being used to work on data pipelines. So I know that many other places have open data sources, but TESS is sort of like a great start, and I would invite you to to look at that. In fact, I had a sort of like a link to the Mikulski data archive, because we're not only looking for things like exoplanets, we're also looking for astroseismology is a new thing. It turns out that just about every star not only has a planet, every star has quakes. It has stellar oscillations, and the stellar oscillations tell you the interior dynamics that are happening with those stars. They have different convective layers, they have different materials, etc., etc. And astroseismologists actually also consider the test data as their plant, their satellite. So yeah, go to the web. I can show you some websites for you to check.
Okay, so thank you. Are there any questions from the audience? Are there any questions in our online? Okay.
So, Dr. Jones, thank you for the wonderful presentation. As a plasma physicist working on or studying ultra compact objects such as neutron stars, uh, what is your stance in the existence or possibility of singularities? Like, do you think there's a mechanism that prevents uh, it the neutron star from collapsing down to an infinitely decimal small point, or is there something beyond the electron or neutron degeneracy pressure?
Right. You're talking about singularities that form from really massive, from black holes. The thing about these things is that they can't be seen because of the event horizon. So the so-called naked singularity has not been observed. In fact, the first any kind of direct observation of a black hole was when we had sort of like a radio imaging of the black hole. I think you've seen that image that was done at Haystack, where they took these super massive black holes and did the image, and it's almost like that, straight from the movie. But the thing is, they don't have the resolution, nor do they have the conditions for finding that naked singularity. So as far as a lot of theoretical physicists are concerned, that's still sort of like within the realm of, hey, let's find one. And I don't know if we'll ever find a naked singularity, but yeah, I'm all open for the possibility.
Okay, so another question.
Okay, sir. With the rapid increase in satellite launches and the rise of private space stations like Axiom Space, so what do you think are the most critical steps for the Philippines specifically to ensure that we are not left behind in this expanding space industry?
Well, first of all, we got to go into space. We got to send people into space, I think, or we have to start making plans for that, because a lot of the human activity that's going to be, as you mentioned, it involves people being there. And as a nation, I don't think we have any experience, or we have very, very little experience of living and working in space. I mean, just like a zero G experience. When I did it, I didn't have any realization of the kind of problems I would encounter. For example, if I were in the space station, how to put things aside and what the kind of footholds. There are a lot of little things um, that are sort of like hard to imagine, and you have to experience. And once you experience these things, then perhaps we can start to innovate along those lines. So yeah, let's try to get serious about actually being there, because as I mentioned before, in a lot of places, once there's a global move to send people in traveling back and forth on the moon and Mars, there's going to be a lot of Filipino crewmen on those flights. That I really believe, because we're a seafaring nation, we're going to be a spacefaring nation. So yeah, once you have that kind of experience, then we can start thinking about the kind of products that are going to be important. But right off the top of my head, I mean, I'm sure there are a lot of ailments that are sort of like specific to Filipinos that we should be working on, or the kind of foods. The kind of foods that they send up right now are sort of like specific to certain tastes. It'd be nice to have adobo in space, but how do you rehydrate adobo, or how do you sort of like rehydrate this or that? So yeah, there's going to be a whole industry on that, but we have to experience it in order to know how to invent products around it.
So this is the last question from our online participant, from Justin Fay of SPCSTD. How can a new space agency like PhilSA transition from having researches to commercial products?
I think that's a question for the Philippine space folks, but from the talks that I've been, especially with Dr. Mark and Dr. Rolly, there are plans to try to reach out to commercial industries, and I think that the Philippine Space Agency is going to be the midwife to a lot. I think of ourselves as the one-stop shop eventually, to basically invite industries. You have an idea, you come to us, we'll try to work out the engineering, we'll work out all of the details in getting you connected, etc. So correct me if just, but the Philippine Space Agency is going to be the one-stop shop for a lot of Philippine organizations. That's
Okay, there's still one question.
Hi, sir. This is a bit technical, medyo malayo ata sa mga list of questions. I get it that marami po kayong instruments, payload na develop with sa HETI yung sa test. I was wondering, since these payloads are contaminant sensitive, so if you do bake out, sir, paano nyo dinidecide kung gaano katagal yung bake out, and at what temperature nyo siya binibake?
It varies, because depends on the kind of materials you have there. Obviously, you don't want to bake it naluto na on the inside. So there are a lot of things that it's case specific. I can talk offline on what you will need, because certain things they would have like different things, like RTVs or whatnot would have different melting points or phase transition points. A lot of things like glasses and metals, they're good to go over a wide range. But when you do the bake out, they may have issues with CTE mismatches that can cause problems engineering wise. You might crack something if you're not being very careful. So anyway, that's the semi-technical answer. It's case to case. Tell me what your problem is, and I'll tell you what the likely solution is.
Sige, sir. Fine na lang.
Okay, so once again, thank you, Dr. Joel Villasenor,
Yeah, thank you for your time.
for generously sharing your time and expertise in the field of space science, technology, and applications. To present the token of appreciation and award the certificate, may we call on Dr. Mark Cesar Talampas and Dr. Joel Marciano Jr. Let me read the citation. Republic of the Philippines, Office of the President, Philippine Space Agency, this certificate of appreciation is hereby awarded to Dr. Jesus Noel S. Villasenor for sharing his expertise and knowledge as resource speaker during the HugNayan Space Science Fora held on May 30, 2025. Given this day at Philippine Space Agency, 11 Eastwood Avenue, Bagong Bayan, Quezon City. Let us all once again extend our appreciation with a warm round of applause. Okay. So okay, thank you, sir. Okay. So to formally close this afternoon's program, may we now invite Dr. Ernest P. Macalalad, the Chief Science Research Specialist from Interdisciplinary Space Missions Development Division, to deliver the closing remarks. Let us give him a round of applause.
So, hello. So as we conclude today's HugNayan lecture, let us take a moment to reflect on the immense insights we've gained from Dr. Joel's compelling talk. Today, we stand at the threshold of a transformative era with more than 12,000 satellites currently or in orbit, with projections of over 60,000 by 2030. Space activity is rapidly accelerating. Cheaper launch costs, reusable rockets, and groundbreaking missions such as SpaceX's Starship are no longer distant possibilities. They are present reality shaping the next chapter of human progress. We also saw how space is not just about the stars, it's about navigation, communications, medicine, bioprinting, material science, among others. And it already represents a multi-billion dollar industry, which is projected to reach about trillions in the next few years. This expansion brings with it opportunities for private space stations, lunar missions, and even dream of seeing the first Filipino in space. So to Dr. Villasenor, we extend our heartfelt gratitude for sharing your time, expertise, and vision during this Fulbright engagement. You have not only informed us about you have not only informed us, but also inspired us to look up with purpose, with hope, and with determination. Again, thank you, and we may all continue to reach for the stars. Salamat po.
Thank you, Dr. Macalalad. We would now like to invite our on-site attendees to come forward for a group photo opportunity. For those joining us virtually via Microsoft Teams, you're also welcome to turn on your cameras and join us for the photo. So let's now all come forward here. There are also snacks there at the side, and there will be a QR code for the post-evaluation form later. So dito naman tayo sa harap for the photo opportunity.